All right, so we're going to continue with chapter 5 today. And today we're going to take a look at what's called conditional probability. And last class, we left off with looking at the formulas for the addition rule, multiplication rule, and I only gave 3 out of the 4 formulas because we need some of this information for this conditional probability in order to do that last formula, and you'll see that. I'm going to do that at the end again. So let's talk about what conditional probability is. And the notation. So conditional probability is when we focus on a portion of the sample space. So remember, the sample space is everyone in the sample, but we're going to focus on a portion. And I'm going to show you that with an example in a minute. I just want to get to some notation. So remember last class, we talked about the notation for probability is this capital P, and then we're going to write whatever event we're interested in inside the parentheses. You guys will have time to practice this in today's team assignment, the day 8 team assignment. And for the notation for conditional probability looks like this, where we have A and then this vertical line, and then you write B. So A is the first event and B is the second event. Now, what this means is that we're looking at the probability of A given B has already occurred or taken place. So what we're saying is this little vertical line is the conditional probability, and that means given. So you know how last class we did the union, so it looked like a U, and that was for the or the intersection, which was the upside down union, looked like a giant lowercase n. That was and, okay, that meant the intersection. This vertical line means given. So that indicates we're looking at conditional probability. So what this says is we're trying to find the probability of A given B has already taken place or B has already occurred. So what we're looking at here is that A is what we call our interest. So A is the event we're interested in, and B is the event that is putting a restriction on our event A. So we call this the restriction. Now this is going to help us with our shading and using our two-way tables. So let's take a look at our two-way table, and we can look at an example. I'm more prepared, like I said. I have this already ready. So we're going to use the same example as last class. So remember I did the poll right at the beginning of class and asked what year student you are and if you're a coffee drinker or non-coffee drinker. So we'll use that same example. So I'm just going to write that. So same example as last class, which was day 8 or lecture 8. So I have my table, my two-way table right here. So let's take a look. Let's find the probability. Actually, you know what? Let me write it out in words, and then we'll write the notation. It gives us a little practice. So let's find the probability of selecting a first-year student if they drink coffee. So what I want you to recognize is that I have two events happening, first year and coffee drinker, right? So there's my two events. You really have to read the wording to know what we're doing with those two events. Are we adding them? So is it an or? Are we multiplying them? Like, is it an and? Or is this a conditional probability? And you see this word right here, if. This indicates conditional probability. So this indicates that we're interested in one thing, but given that something else has already taken place, okay? So that's what I was talking about before here, where I have my interest. So that's what I'm interested in, but given that I have this restriction of B already on it. So let's read it again. So the probability of selecting a first year. So that's what I'm interested in. I'm interested in the probability of a first year. So I'm going to write my notation, capital P, and then you can just write one, you can write first, write it out, first year, whatever you want to do, if they are coffee drinkers. So the coffee drinker is my restriction. So I only want to know what's the probability of choosing a first year out of those coffee drinkers. That's what I'm looking at. So given, and I'm just going to use a C for the coffee drinker. Okay. So when we look at this on a two-way table, this is so simple. I love using the two-way tables. It just takes out like that memorizing or trying to remember all these rules for the formulas. So I love this. So what I'm going to do is I'm going to outline my restriction, which is the second part of my probability. So that is coffee drinkers. I'm going to outline that with this dotted line. So I'm just going to outline all my coffee drinkers. I tend not to box in like the total because I don't want to add that up by accident. And what I'm going to do is I'm going to shade my interest. Okay. I'll write this down too. So I'm interested in first year students that are coffee drinkers, right? So I'm interested in that. And remember, what we do is we add up all the boxes that are shaded just once, right? So let me write this down here so we have it. So we're going to outline, so that's what I did with the dotted red line, the interest, or the restriction, which here in this example is going to be coffee drinkers. And we're going to shade within that outline the interest. And that's going to be my first year students. Okay, so we can see that I did that already. I outlined and I shaded. Now for my calculation here, or I don't really want to say calculation, but for getting my numbers, my numerator is always going to be that shaded number. So it's just 7 out of the denominator. Now the denominator is just my restriction. So that's going to be the 20. So right here, my probability of choosing a first given their coffee drinker is 7 out of 20. Let me just write this. I like to have little extra notes. So if anyone goes back to look, they don't have to second guess what we did. Okay, there, that's the division, all right? Shaded over outline. And that's how we can find conditional probabilities using a two-way table. I love it. It's so simple. Remember, guys, we're not spending a lot of time on probability at all because we're just preparing ourselves for what we have coming in the future chapters. But let's take a look at another example. So we're going to use the same information. So example 2 here. Again, I'm going to write it out in words so we can practice writing it in notation. I think that's really helpful. So let's find the probability of choosing a coffee drinker given a third-year student. So I want you to know there's several words to indicate this conditional probability. And I'll write some of them down at the end because I want you to know. I have three that I could think of off the top of my head right now, real quick, but I'll write them down so we can just be kind of more aware. So right here, again, I need to recognize what words we're using here and like what we're given. So again, we have two probabilities, right? Two events, I'm sorry, that I want to say. So the one event is coffee drinker, another event is a third-year student, right? So I want to know, what is the probability of choosing a coffee drinker? That is my interest. So I'm going to say, okay, I want to know, what is the probability of choosing a coffee drinker? And right here, this word given. This word given right here means conditional probability. It's just one of those words. So over up here, it was if, and now this one's given. So it's saying, what's the probability of choosing a coffee drinker given that the student's a third-year student? So knowing already that it's a third-year student. So third year has already taken place. So here I'm going to use my vertical line indicating given, and then I'm going to write just third-year student. Remember, you can abbreviate all you want, however it makes sense for you. I am not picky about that. Okay, so let's just erase what we had here for this last example, and we will take a look at this again. So again, I'm going to outline the interest, and I'm sorry, I keep saying the wrong thing. I'm going to outline my restriction and shade my interest. I'm sorry, I don't know why I keep saying the wrong thing. So I'm going to outline my restriction, and I'm going to shade the interest. The interest is always what we're trying to find the probability of. So what's the probability of choosing a coffee drinker? Right there. I'm interested in that, right? That's what I'm trying to find my probability of. So let's take a look. So my restriction is that they're a third-year student. Oops, almost used the wrong marker on that. So again, I'm just going to kind of outline it with like a dotted line. And I'm going to shade in coffee drinkers out of those third year. So here, so we can see, okay, my numerator is my shaded region, which is 2 students out of my total third-year students. Well, look at that. It is also 2. So here it's a 1, it's 100% chance, right? 100% or a 1 probability. That doesn't happen often, but this is what happens. So you guys, you know what? I'm glad this actually happened. So you know, this was real-time data, right? I just pulled it last class real quick, right at the beginning of class. We can see it comes out like as a 1, which is like rare, but that's what happens. So I want you to know when we have real data, nothing's perfect, right? Ideally, I probably would have liked to see something more of a fraction and less than 1, but that's okay. This just means that I have a 100% chance of that happening, okay? So keep that in mind. When we're dealing with real life data, which I usually am using, it's not perfect. Nothing's perfect, right? Things in life are not perfect. Okay, so that's our second example. Now I want to go through the formulas. I want you to know with the formulas, I'm still going to use the table, meaning I'm going to pull my information, my numbers from the table. I want you guys to know when we're working with probability, like I said before, and I've said it a couple times and already once today, this is not like a mandatory topic. I just think it's useful for us. I will always give you this two-way table anytime I'm asking you to do a probability. Except for on the like team assignment, I might throw a couple like different things out there for you, but I want you to know, like anytime I give you something that's gonna be graded like an exam, I will always supply the two-way table. You always have the choice to choose to calculate probabilities based on the two-way table, or you can do it based on the formulas. Okay, so I just like you to know that. So you can choose whichever way you want to calculate. So let's take a look at some of these formulas. So we're going to pick up where we left off last class with the formulas. So remember last class, we were looking at the multiplication rule. So we were looking at, let me see how I wrote it, because now I don't remember how I wrote it. And I want to be kind of consistent. I got to pull it out of my file here. I already threw it away. Here it is. Okay. I just want to be consistent in writing it same way. Here we go. Okay, so we were looking at the probability of A and B. Okay, and the and here was the key. It's like the key word. It's telling us what we're doing with these two events. So and means multiplication rule, right? So we already talked about that last class. And I gave you the special case. So actually I'll show it because I have it right here. So last class we left off right here where we had the probability of A and B, and I gave you the special case. So probability of A and B means I'm going to use the intersections. I'm going to multiply probability of A times probability of B. That was my special case. Now to continue with this, I want to give you the general rule like I did for the addition. For addition, I gave you both the special case and the general rule. So if we're looking at the general rule, we have the probability of A and then intersection. So it's that upside down U or a large lowercase n. It's my intersection. Probability of A and B equals the probability of A times the probability of B given A has already taken place. So you see why I couldn't give this to you last class? I had to wait until we can introduce this conditional probability because this general rule uses the conditional probability. So let me write a couple of these things down. So this right here is the general rule. So I want you to know the general rule you can use anytime, right? The special case, you have to have something that takes place. Like here, A and B must be independent, right? So A does not affect B and B does not affect A. So if we don't know if that's the case or not, then you can always go back to the general rule and it will work out either way. All right. So that's my general rule. Let me just having some issues. Okay, here we go. So this is going to be the probability of A. I'm just going to write it down, the wording behind this, because I think that might be helpful rather than just notation. So the probability of A times the probability of B given A has occurred. Okay. And I also want to just make a note, like I already just said it, but I'd like to write it down. If A and B are independent, then the probability of B given A will just equal the probability of B. So then it brings you back to your special case up here, okay? So what I'm saying, if A and B events are independent, meaning one does not affect the other, then placing that restriction of A on B doesn't affect it, then it means it's just the probability of B. And it brings you back up here to special case. So that's all I'm just mentioning. And that's from that last class. Okay. All right, now let's take a look at the conditional probability formulas here. The probability of A given B. Given is that keyword that we're looking at. This is conditional. Now, some people get very confused by this, and I don't want you to get confused. My conditional probability relates directly to this formula up here for my A and B. I'm just going to solve for that conditional probability. I'm going to divide both sides for the probability of A. I don't want you to get confused by that, and some people do. So I'm going to write it actually in a different way with A and B instead of B and A like that. So the probability of A given B is equal to the probability of A and B divided by the probability of B. These formulas are not meant to take one and plug it into the other. And that's what I mean that some people get confused. So if someone's trying to find the probability of A given B, it's not meant to plug it in here to solve and plug this in here. It's not meant for that, okay? You're given specific pieces of information, and what you can use to plug in is what determines, how you can use your formulas and what formulas. So this is not meant to plug into here. It's not meant for that. It's just a rearrangement of this formula for this formula, okay? So we don't have like a special case or anything for my conditional probability. We just have that one formula. Guys, remember, you do not have to use any of these at all. So I'm going to make another note about independence here. So if A and B are independent, then the probability of A given B is just equal to the probability of A. Think about that. Think about what I'm saying here. If A and B are independent, then the probability of A given B is just the probability of A. Look at what would happen up here. If A and B are independent, then this formula would just be the probability of A times the probability of B, right? It would be my special case. And then the probability of B's would cancel out, and I would be just left with the probability of A. So it should make sense. Okay. So again, we don't have to use the formulas, but I'm going to show you some examples. So let's take a look at a couple examples using these formulas. Like I mentioned already, we will be using the table information. So we're going to get our information, our numbers from the table for calculating these probabilities. Let me grab our table. So we have that. And so we're going to look at example. I'm just going to write again here, same as last class. So we have something to refer back to. Okay. All right, so we have this. So let's take a look at first finding the probability of choosing a fourth year student and a non-coffee drinker. So I'm going to abbreviate NC for non-coffee drinker. I didn't write it out in words, but I can. Maybe I'll do that below it. Okay. So we have it. I like to have everything available. So I'm looking at the probability of a fourth year and a non-coffee drinker. So let's take a look at the formula like I just gave you. This is my and. So it's the probability of the first event times the probability of the second event given the first one has already taken place. I'm just going to write it in terms of my events I'm looking at here. So here I'm going to have the probability of a fourth year times the probability of a non-coffee given the students of fourth year, like that, okay? All right, so I'm going to bring this down here. I should have just wrote it down here to begin with. So then we can see. I'm not going to use table shading. I'm using the formulas and I'm going to multiply. I'm going to pull the information from the table, okay? So I have my numbers here in my table. What is the probability of a fourth year student? So my fourth year students, I have 2 out of 32. So right here, I just have 2 out of 32 students for fourth year times. Now we're going to look at the probability of a non-coffee drinker out of the fourth year student. So I'm looking at the probability of a non-coffee drinker out of my fourth year. So we're kind of using the table like we would with the shading. So I'm looking at my fourth year students right here. So I have 2 of them. Out of them, only 1 is a non-coffee drinker. So I have 1 out of 2 here. What happens is these 2's cancel and I'm left with 1 out of 32. Okay, and that's my probability of choosing a probability of choosing a fourth year and a non-coffee drinker. Remember, if we were looking at the tables and the shading for an and, you're looking at that overlap. So you're looking at the intersection fourth year coffee, 1 out of the total. Get the same answer. All right, let's take a look at another one. So let's take a look at the probability of a second year given they're a non-coffee drinker. So remember the formula here. I'm going to pull this up here. So my formula for this, for my given, my conditional probability is that I have probability of A and B. So it's going to be my second year and non-coffee. So it's like my intersection divided by just the probability of a non-coffee drinker. Okay. And actually go to the right here with that. So again, I'm going to use my table to get my information, get my numbers. So I'm looking at the probability of a second and non-coffee. That's the overlap of second and non-coffee. So right here, it's 5 out of all of the students, 32, divided by just the probability of a non-coffee, which is 12 out of 32. When we have this, we can just look and say, oh, the denominators cancel. You can keep, change, flip, meaning you could say it's 5 over 32 times. So keep the numerator, change my division to multiplication. I'm going to flip the denominator like this. And you can see those 32's cancel, leaves me with 5 over 12. You guys, I don't need to see all the algebra. I'm just telling you, I'm just showing you how I'm getting here to this result, okay? If you just said, oh, this is equal to 5 over 12, I'm good. I'm good with that. Again, you don't need to reduce any answers. Not that you're gonna reduce this, but I'm just saying in general, you can just leave your answers as is. You don't need to reduce and simplify your fractions. We are not an algebra class.